The title of my talk is Fourfold Composite Quantum and the Emergence of Space-Time, Energy, Gravity, and some Implications. And this is more of a conceptual model. And it's not dissimilar in concept from what Dr. Alexander had presented earlier in terms of getting to mass without mass. Because essentially, what I'm going to speak about and what I'm going to present just at a high level is a mathematical model that takes light at some kind of abstract, pure space and then precipitates it into mass and matter as we experience here. And that's the essential thrust of this talk. It's going to be split into a few different parts. So one, I'm going to go into the mathematical model of light itself. Second, I'm going to look at quantum theory from this light-centered interpretation and essentially look at the emergence of space-time, energy, and gravity. And I'm going to revisit at the end of that some implications for an alternative interpretation of quantum theory. And then finally, if I do have time, what I'd like to do is take this fourfold quantum, this composite quantum, and apply it to a few different cosmic scenarios, just to see how it might work out. And of course, again, this is all conceptual. There's no experimentation that's been done on this. But I would welcome, through the course of the next couple of days, your perspectives, your thoughts as you see this, and especially since so many of you have spent decades on this, would love to get some further ideas for even collaborations on taking this work further. So light. So this is a summary of the mathematical model of light. I'm going to deconstruct it over the next few slides. So essentially, what we have here is, right. So we have light that exists in some abstract pure space, and then we have light that exists as we know it at the finite speed of 186,000 miles per second, and there's certain implications for the reality that is generated by virtue of light at the different way that it exists. And then there's a precipitation that takes place between this abstract space and this finite space. And quantization, to me, is really the process of precipitation, which I'm going to speak about in more detail. So looking at the very first kind of layer, so that's the layer that exists here. To kind of just ground it, I want to first look at something that we're pretty concretely familiar with, and then I'm going to step back to this kind of abstract space and then look at the precipitation. So light at sea, so light traveling at 186,000 miles per second, a situation where if we think about light that's coming from the sun to the earth, then by virtue of it being finite, there's a few different things that occur that structure the nature of our reality. So let's think about that. So first of all, because it's traveling at a finite speed, and if you're on a light beam, say that's between the sun and the earth, then what you'll see is that from the point of view of that light beam, there's going to be a past, there's going to be a present, there's going to be a future, and that's simply by virtue of light traveling at a finite speed. Now, if light were traveling at an infinite speed, you wouldn't have a past, present, and future. There would be some other notion of time. So there's past, present, future that's pretty concrete, and then I would also hypothesize that light, the speed of light sets, in a sense, an upper limit to the nature of reality, the way that we experience it. But if we flip it, there's a correlation with Planck's constant. So I would argue that Planck's constant is inversely proportional to the speed of light. And it gives a lower bound to the nature of reality as we experience it. But because light is traveling at a finite speed, what this means is that there's a chance for accumulation of energy to occur, which is what Planck's constant really is related to, is an accumulation of energy that then allows matter to emerge. as a result of that. So what we're saying is that because of the finite speed of light, there's four very concrete things that emerge in the reality that we experience. There's a past, there's a present, there's a future, and there's matter. And this is purely due to the finite speed of light in this mathematical model. Now, the question is, what does past, present, future? So if we look at the essence of past, present, future, and matter, and here I'm just trying to abstract it into a simple mathematical model. So when we look at the past, it's really everything that exists around us. So everything is a result of forces that have occurred, and what we see is kind of like the finiteness. So when I look out at you, at this room, everything is a result of the past. And so there's a physicality to what's the past represents, a physicality, if you will. Now the present is, by contrast, a coalition of forces, of dynamic forces, and only one or two, or perhaps a subset of these forces will emerge at any point in time. So there's a vitality that's kind of captured in this notion of the present. And so what I've just taking a summary point here, so P for physical, V for vital. The future, when we think about the future, the essence of that is something that is going to be worked out, something that is being worked out, core ideas. So there's an essence of mentality there. And then matter really allows connection between these different emergences that have occurred in the universe due to a finite speed of light. So if I were to just abstract the essence of the past, present, future, and matter, I come up with four states that I refer to as P, V, M, and C, which I'll come back to in more detail. Now let's look at light at infinity. Now light at infinity, so imagine that you have a light source in a volume of a space. So that light is going to be able to project itself instantaneously in that whole space. So there's a quality of omnipresence. It exists simultaneously all over. There's a quality of omnipotence, because if anything else arises within that space, then the nature of light will overwhelm it sooner or later. There's a quality of omniscience, because that light, everything being of the nature of light within a volume, that light has a knowledge of everything that exists within that space, and so there's an omniscience, and then everything is connected by the nature of light, so there's a kind of omni-nurturing or an omni-loving. So there's four qualities that I would hypothesize exist in this space in which light travels infinitely fast. Now, if I were to just get to the essence of those four states, I would call them presence, power, knowledge, and harmony, from omnipresent, omnipotent, omniscient, and omniloving. So what we have here is that the top layer, there's the beginning of a mathematical model where we have the essence that exists at this infinite speed, we have the essence that exists at light traveling at a finite speed, and the reality is that when we look around us, there's infinite diversity. So there's no two things that are alike. And yet, in this mathematical model, they all emerge from things that are seemingly similar, four things that are seemingly similar. So the question is, how do those things that are seemingly similar become infinitely diverse, materially diverse? And so that's a mathematical problem, and the way that I chose to solve that is essentially by creating a series of transformations from that layer of infinite light to this layer of finite speed, in which infinite diversity emerges. And so the first layer is what I call the master sets. So as I had kind of gone over very briefly, there's the essence, the presence, power, knowledge, harmony. So what are presence, power, knowledge, and harmony? We can call them kind of four sets of vibrations, four sets of possibilities that exist in light. The master sets are a diversification of those sets, so that what we really have is sets that are structured around these four properties, these four sets of vibrations, that have a vast amount of variation, yet centered around that central kind of sense of presence, power, knowledge, and harmony. So these master sets therefore allow, practically speaking, an infinite number of elements to emerge from these four kind of key vibrational elements. And here, just a summary. So what we're saying is that when we look at this, there's a set of presence, there's a set of power, there's a set of knowledge, and there's a set of harmony. And then the question is, how does this become the infinite diversity that we experience around us? And the diversification essentially takes place by a kind of multiplication, if you will, between the elements of these four, now practically speaking, infinitely large sets. So if you take elements from each of these four sets and you multiply these elements together in different variations and combinations, you can come up with essential signatures or seeds that would create the infinite diversity that we experience materially. So any kind of manifestation of matter or mass can, in this kind of mathematical model, have a signature or a uniqueness that is derived from something that's seemingly abstract. So light becoming, precipitating into something that's more and more material. So just summarizing the key idea here, what we have is that the reality of this layer here is basically a function of the multiplication of the sets, the master sets that existed at this layer, and these then become seeds for the infinite diversity that shows up in these physical, vital, mental, and connective kind of modes, if you will. So this is the essence of the mathematical model. Now the question is, what's quantization in this? So, before I get to space-time matter, so here I want to say one thing, and that's that quantization is, let's think about it this way. It's an accumulation of energy, it's an accumulation of quality, and it's a translation from, the way I see it, from one layer of reality into another, more concrete material layer, when you compare it to that abstract layer. So there's many, in this point of view, there's many kinds of quantizations that are possible. There's a quantization between this layer and this layer. There's a quantization between this layer and this layer here. There's a quantization between this layer and this layer. So there's different schemes of quantization that are possible. And again, the essence of this is that the quantization, what we're saying is that the purpose of quantization is pretty simply, is to take what's contained in light, is what is codified in light, and make it more material at some other more material layer of existence. So that's how I would specify what quantization is. So now, looking at the emergence of space-time, energy, and gravity. So when we think about, so this was what I was just talking about, quantization, and again, just summarizing, there's different kinds of quantization possible, and when we think about space, time, matter, and gravity, these can be summarized essentially as byproducts of quantization. So you think about space, coming back to the notion that in light, according to this model, light has something that we're calling knowledge that's implicit in it, it's codified in light, and space is essentially the diversification of this knowledge that shows up as infinite number of seeds. So space is a quantization such that you have an infinite number of seeds that capture some essence of what something is going to be, and that really determines what space is. Again, just tying this back to the key concepts here. The concepts are very simple in this mathematical model, and I want to, if there's nothing else that we get out of this talk today, I just want to kind of hit this point home, that light, here, this is a symmetrical model of light. There's a symmetry that is saying that at some abstract layer of light, we have four essential qualities that exist in that layer. And when we precipitate this light, we come up with light as it exists in this universe at 186,000 miles per second. And essentially what's being materialized here is the essential codification in here. The codification itself is a result of quantization. And space, time, matter, and gravity are all emergent phenomena that emerge from this reality of light. So when we think about space, space is actually a projection of this property of knowledge that we're hypothesizing exists fundamentally in light. Time is the property of power, and I'm going to speak about why. Matter is the property of presence, and gravity is the property of harmony. So there's the essential qualities of light that manifest materially as, in this cosmos, in this universe, as space-time, matter, and gravity. So again, space-time, matter, and gravity are emergent phenomena. Light, in this point of view, is the fundamental reality, and everything else is a quantization based on what's in light. So now getting into some of the details of space. So there's a couple of, again, this is just a mathematical model, and here are a couple of equations that really specify how we can think about space in this mathematical model. But to summarize, space again is an emergent property of light. It's structured by infinite seeds of knowledge. So if you imagine that in light there's infinite variety possible, then they show up as different seeds, and this seed creates what we experience as space. Now this is not dissimilar from current versions of quantum loop gravity, for instance, where you also have kind of the quantization of space that seems to emerge as a fundamental reality of what what space is. Now, the practical aspect, the quantization, the reason why I think quantization is so important is because it assures that this knowledge is not dissipated. So whatever is existing in light, if light were to continue to travel at an infinite speed, then whatever was in light could never be accumulated, and it would just disperse instantaneously. But because of quantization, what's happening is that what's essentially in light is able to manifest more materially. And therefore, quantization plays a key role in creating the reality that we experience here and in the fundamentals of space-time, energy, and gravity. So when we look at time, we can think about time as being the inevitability of these seeds that exist in space emerging and maturing. So if we're saying that space exists of infinite seeds, then these seeds have a purpose to them, they have a trajectory of development to them, they have a maturity to them, and time is essentially a measurement of that maturity. So in this perspective, time is again a quantization by which the essential nature that's embedded in the seeds of knowledge can mature in a material frame that we experience here. So time can be experienced in many, many different ways. Again, there's no absolute time as there is no absolute space. These things are infinitely diverse. And the quantization assures that essentially that the power in the seed is not dissipated but can accumulate to express a phase maturity. And that's the purpose of time. Now, when we think about energy or matter, it's essentially the energy also can be thought of as an emergent property of light, and it results in matter. And again, the quantization, and this comes to the notion of the Planck's constant as we're familiar with it. And what I'm proposing in this mathematical model is that there's possibly different kinds of Planck constants. We're familiar with a Planck's constant that we may be able to measure the value of. It may be that the a Planck's constant for time, energy, matter, and gravity is the same or not. But the fact is that what is being proposed in this mathematical model is that there could be different kinds of Planck's constants, each of them related to the quantization of these four fundamental kind of pillars of existence, of energy as we know, the Planck's constant, but in addition there could be a Planck's constant that's specific to time, that's specific to energy, and also specific to gravity. Now, when we think about gravity, it's really this notion, it's capturing this fourth aspect of what's implicit in light, which we may call a harmony or mutuality. And sets the interrelation between the seeds that exist. So gravity is really expressing the interrelationship between these seeds that exist in space. And to express itself and to assure that this essential quality of light is not dissipated, again there has to be a quantization. And that quantization therefore could be a different kind of quantization that exists in time, space, and energy. And so what we have is that what I propose in this, or what emerges from this model, a corollary of this model, is that you have these fourfold quantum that exist together as a composite quantum that would, or anything, and it's essential to how that essentially will experience itself and how things will be experienced in this material realm, essentially. So just summarizing this notion of fourfold quantum, the idea of a composite quantum, a fourfold composite quantum, is capturing that innate oneness and suggesting that even in the material realm, there has to be a oneness that exists in the way that this quantum kind of manages space, time, energy, and gravity. They have to exist together. There can't be a separation between them in this model because they're all essentially one within light. So these four quantum fields, if you will, that we know as space, time, energy, and gravity act as one composite field. What I've written about elsewhere, and the series of 6 books I've written on cosmology of light, gets into this fourfold organization of matter. But I wanted to make the point that, mass from no mass, or something material, architecture of quantum particles, if we think about the architecture of atoms in the periodic table, if we think about the architecture of molecular plants in any living cell, we'll see that there's a fourfold architecture that animates each of these things. So the standard model, I've made a slight I've creatively enhanced the standard model, which consists of fermions. So I split that into the quarks and the leptons as two separate groups, and then you have bosons as a third group, and then you have the Higgs boson and similar particles as a fourth group. And to me, that essentially is a precipitation of these four qualities that are in light at the quantum particle level. And here, what I'm essentially proposing is that light's properties of knowledge, presence, power, and harmony that show up as space, energy, time, gravity at the quantum level. Knowledge shows up as quarks, presence shows up as Higgs boson, power as leptons, and harmony as bosons. If you look at the boson level itself, so the way that these fundamental forces operate, then I would propose that gluon, that is basically keeps all quarks together, is a property of knowledge. Photon is a property of presence. W and Z bosons of power, and graviton of harmony. If we think about the atomic level, then we already know that the periodic table is again structured into 4 architectural parts: the P shell, D shell, S shell, and F shell. And here we can also draw a one-on-one or see an essential similarity or a symmetry in this precipitation from abstract light to material form, where we have the P shell that represents knowledge, D shell presence, S shell power, and F shell harmony. And then cellular level, it's known that any living cell has 4 molecular plans embedded in it, and those 4 molecular plans have nucleic acids, proteins, polysaccharides, and lipids. And if we think about the nature of nucleic acids essentially is the repository of a cell's knowledge and way of being, so that's all about knowledge. Proteins are the workhorse of cells, that's about presence. Polysaccharides provides the energy of power, it's all about power. And lipids provides compartmentalization in the cells, that's all about harmony. So what we're seeing is that this essential model of light is precipitated into more and more material forms and structures reality as we experience it here, right now. So I came across a quote just in a book I was reading just last week. And maybe perhaps some of you, it's a fairly new book. It's called The Quantum Astrologer's Handbook. Anybody read that? No, there's a quote about Newton, an alchemist through and through, wondered about whether solid bodies and light are interconnected, and whether light is the source and activity of solid bodies. And it struck me when I read this quote that essentially it's capturing what I'm trying to put together with this kind of model of light, this mathematical model of light. So I just wanted to draw attention to it. And one of the things that, if we think about quantum physics today and the way that the common thought about it, light is really a result of a carrier boson, which we call a photon. But I would propose, in fact, something different, and that is that light does not need a carrier, and the range of bosons are generated from light, as are all other layers of matter, and that's essentially what this model here is summarizing. And so we have gluons that bond quarks together to ensure integrity of nucleus so that knowledge is propagated in behavior of atoms. We have W and Z bosons that allow neutrons to change to protons, thereby releasing power or energy. We have photons that allow matter to be present by device of the electromagnetic field. And we have graviton, the kind of hypothetical graviton that allows collectivities of matter to form, thereby expressing harmony. How am I doing on time?
I guess 9 minutes.
9 minutes, okay. So I just want to spend the last few minutes to talk about, so here, what I'm proposing is essentially an alternative interpretation of quantum theory. And in this alternative interpretation, I want to go over some key points. And one is that we already have a pilot wave theory, which was the result of De Broglie and Bohm's work. And in that pilot wave interpretation, we have the duality of both particle and wave. And I believe that a couple of our speakers are going to speak about the famous double slit experiment. But what I wanted to say is that when we think about this theory of light, what it is proposing, the mathematical theory that I've suggested today, it's proposing not a duality but a quadrality of light. And I kind of typify that as a block field wave particle quadrality. And so essentially what it's saying is that light is always traveling in four components. It's not just a particle, it's not just a particle and wave, but there's also a field and a block. And so there's a cohesiveness and completeness by which light travels in this manifestation and beyond it as well. And so when we think about a couple of points, as much as I can get through in the next few minutes, the wave-particle duality as has been interpreted by De Broglie and Bohm. There's particles are guided to regions of constructive interference of waves, and that's how the kind of interference patterns are explained. And then the photoelectric effect is due to light particles traveling at c, but essentially, this is kind of a subset of this kind of bigger model of block field wave and particle. The notion of apparent randomness that's very big in the Copenhagen interpretation of quantum physics, and I believe on also on what superposition is built, and perhaps Michael can speak a lot more about this. Here I'm just looking at this area from a philosophical, mathematical perspective as somebody who's interested in an alternative interpretation. But again, there's people who've done years of work, so I look forward to your comments, after this talk and your kind of interaction with you in the next couple of days to understand, some of these points from a different point of view. But here, essentially, what's being proposed is that because light travels as a whole, so it's traveling as a particle, wave, field, and block simultaneously, and our physical instrumentation today can detect particles that travel at c or less than c, but it cannot detect anything traveling faster than c. And yet waves, if you think about it, wave is a dematerialization of quanta, and therefore, to me, it proposes that light is traveling faster than c anyway. So randomness appears to be random only because the wholeness is kind of hidden behind it. The point being that there's not an entire randomness as the interpretation of quantum physics today holds, but there is something that we're not tapping into deeply enough that would give us an insight into how perhaps this randomness can be thought of differently. Another key point of this kind of mathematical model is a functional view. So what's being proposed, and this was way back, if you think about Democritus and his kind of conceptualization of atoms, he had suggested like atoms of salt being sharp, atoms of water being smooth. So there was a functionality that was being represented in this notion of atoms. But if you think about what I'm proposing here, it's all about functionality, because let's go back to this essential model here. And here, essentially what we're saying is that anything that appears materially is a function, it's a function of the infinite number of elements that exist in these master sets that are projected from the essential quality of light. So all of existence is a functional existence, meaning that the way that we interpret things, we have to understand the function that any kind of item is trying to play out in its existence. Anyway, I see that moderator is standing up, so I want to just wrap up here. But I look forward to your comments and interaction for the next few days. Thank you.
Okay, so we have one more speaker.